Welcome back. We now turn to our second set of presentations. To remind you, we will have a group discussion and audience Q&A following these two presentations, and you are encouraged to submit questions at any time using the Slido link provided on the screen behind me and posted in the chat feature of the Zoom webinar. Our first speaker of this session is Divya Solomon, doctoral student in resource policy and behavior at the School of the Environment and Sustainability at the University of Michigan. Divya will discuss migration and adaptation to climate change in rural households in South Asia. And our final speaker of the program is Dr. Nikki Rust, Head of Land, Agriculture and Nature at the UK Climate Change Committee. Dr. Rust will discuss the critical question, how can we transition to climate-friendly diets? Divya, the floor is yours.
Great. It's really nice to see you all here, and I'd like to thank the organizers for inviting me for this event. So my name is Divya, and I'm a PhD student at the University of Michigan. My research focuses on migration and adaptation, and that's some of the work I'm going to be presenting here today. So as you all know, environmental change, including climate change and natural resource degradation, is negatively impacting agricultural productivity and livelihoods throughout the world. At the same time, households are increasingly adopting off-farm diversification processes. In my research, I examined the dynamics between these processes, and I used case studies in South Asia. Now, I focus my work in South Asia because it's one of the regions in the world most vulnerable to the effects of climate change. This includes increasing temperatures. In this figure, you can see the increase in wet bulb temperature, which is a measure of heat stress, and it's concentrated in the northern parts of South Asia. We also see monsoonal rainfall patterns are changing, including increasing wet and dry spells. In this figure from June 2020, you can just see the scale of flooding in the region due to an extreme rainfall event. Now, these changes will severely impact agriculture. You can see that climate change will reduce agricultural production by almost 20%, which is significantly more than other regions across the globe. This will have an adverse impact on food security in the region, and this is of a special concern because almost 30% of this population already experiences some form of food insecurity. In addition, climate change will impact the livelihoods of almost 250 million smallholder farmers in the region. Now, in response to these increasing climate risks, farmers are adopting a suite of practices to reduce losses. These include on-farm adaptations, which include behavioral modifications such as changing of sow dates, adopting new technologies such as new varieties of flood and drought-resistant crops, and increasing inputs such as fertilizers, pesticides, and irrigation. In addition to this, farmers will change their crop management strategies, adopting more climate-resilient crops such as millets. Now, these crop-level adaptations can have a significant impact on the yields. It's estimated that adaptation can reduce the impacts of climate change by 7 to 15%. In this figure, you can see the amount of yield change for rice and wheat, two of the major crops, under increasing temperatures. As you can see, there's a significantly less yield loss with adaptation compared to without, and in some cases, in rice, you can see that there's actually a positive gain from adaptation. However, farmers face significant barriers to actually uptaking these technologies. Some of the major barriers include a lack of financial capital. There are labor constraints, as well as a lack of information, as well as a lack of supportive institutional arrangements. In addition to these factors, with increasing climate risks, farmers may not have the motivation to adapt anymore, and we may prefer to just move out of agriculture or reduce the amount of agriculture that they practice. Now, in addition to these on-farm adaptation practices, farmers will also use off-farm diversification, and one of the major strategies that we see that farmers are using is migration. Now, although in the media we often see migration as this movement of large groups of people because of some kind of natural hazard or catastrophe, In reality, migration are often small movements within countries, and is already being practiced by 1/4 of all rural households in the global south. Now, with the added pressures from climate change, these numbers are estimated to grow to almost 50 million by 2050. In my research, I take an interdisciplinary approach to define the drivers of these adaptation processes, and then looking at the interactions between different types of adaptations, and then I consider what this means for the household. I specifically address how climate change impacts migration, and then how migration in turn is impacting adaptation. Further, I look at if this migration is adaptive for the household, and today I'll be presenting on 2 case studies in South Asia. In my first case study, I look at farming systems in semi-arid regions in rural India. In this study, I use socioeconomic, agricultural, and migration data from 800 households, followed across a period of 5 years. Doing this, I can understand how households use migration to adapt to climate risk, and how this impacts household consumption. So what we find is migration is very common among households in the region. Nearly 1/3 of all households practice some form of migration along with their agricultural practice. Most of the migration is to urban destinations, while you have still 10% of households that send migrants to rural areas. Migration to urban areas generally provides more wages and is in the construction industry and as well as in the service industry, while rural migration is mainly for agricultural activities and generally pays less. In this figure, I try to show the spatial distribution of migration. The circles represent the distances that migrants will travel. You can see that rural migration is generally within the same district as well as the same state, while urban migrants will sometimes travel hundreds of miles to their destinations. So in my first part of my research, I really explore how climate risk is impacting migration in the origin regions. Here I consider the impacts of short and long-term rainfall and temperature shocks on a household's decision to send an urban or a rural migrant. So I use a simple binary logic model with household and time fixed effects to map the effects of climate variables on migration. On the x-axis, I have the standard deviation of the climate shock, and the y-axis gives you the beta coefficient of the effect. I find that rural migration is mainly impacted by short-term weather shocks. And from discussions with farmers on the field, we find that households choose to migrate to rural areas in response to short-term weather shocks because rural migration requires less planning, capital investment, and social connections. And considering the effect on urban migration, I find that urban migration is impacted both by long as well as short-term shocks, but the magnitude of impact is more for longer-term shocks. This could be because urban migration requires considerable social and financial resources that takes time for people to generally mobilize, and this limits its feasibility as being used as a short-term coping strategy. Now, in the second part of my research, I consider if migration is really adaptive for the household. Here I consider the effects of migration in mediating the effects of short and longer-term climate shocks on food and non-food consumption. I do this using a quantile regression. The regression allows us to see how adaptive migration is for households in different parts of the consumption quantile. On the x-axis, I show the consumption quartile, and on the y-axis, I have the beta coefficient of the interaction term between migration and the climate shock. I find that rural migration mediates the effect of short-term rainfall on non-food and food consumption, and this is particularly true for households in the lower end of the consumption distribution. This suggests that migration to rural areas, which is generally conducted by households from the lower end of the consumption spectrum, provides lesser remuneration, but it can help households with daily consumptive needs. Now, considering the effects of urban migration, we find that urban migration reduces the effects of weather shocks on both food and non-food consumption, particularly for the middle and lower quantiles of consumption. So taken together, we can say that migration is an important coping strategy, particularly for the poorer households who are most likely to reduce consumption in response to weather shocks. So overall, we found that households will engage in two forms of migration. One form is a reactive, more distressed form of migration to rural areas, and a more economic forms of migration to urban areas. We see that poorer households would migrate to areas closer to their origins to respond to short-term weather stressors, while urban migration is generally to longer areas, to longer distances, and can generate more incomes, but is not necessarily available to all households. So in my second case study, it's based on fieldwork that I conducted in 3 countries in South Asia: Nepal, India, and Bangladesh. Here we interviewed 2,000 households and asked them questions about their migration practices, their agricultural practices, and how they perceive the impacts of climate change. The selected regions have similar wheat-rice cropping systems, with wheat grown in the winter and rice grown in the rainy period. These sites are also known for having large internal and international migrant flows. Now, thinking about how migration varies between different countries, we find that households practice both shorter-term migration, which is for periods less than 12 months, as well as long-term migration. However, we see that shorter-term migration is more prevalent in Bangladesh and India. We also find that most of the migration that happens in Nepal is to international destinations, while in India and Bangladesh, most of the migration is within the same country. In the first part of my research, I analyze how climate perceptions, socioeconomic, and regional conditions shape the migration choices of households in these particular countries. Now, I choose to look at perceptions, as perceptions really embodies both an individual's belief systems as well as their exposure to a particular climate stressor, and they can be a better predictor of how the household will adapt. We found that households that practice temporary migration have a worse perception of climate compared to households that don't. We also find that while wealth is positively associated with households that practice long-term migration, access to resources, particularly borewells, negatively impact short-term migration. These results suggest that short-term migration is used by poorer households with lesser access to resources to mediate the effects of climate change, while longer-term migration is an economic investment by wealthier families. In the second part of my research, I focus on the impacts of migration on farm practices. Now, to understand how migration is impacting farm adaptation, we first consider how migration is impacting agriculture as a whole in these 3 countries. We initially asked households how they've changed their farming practice because of this migration that they practice. 75% of all households in Nepal reported reducing their agriculture in response to migration, while Bangladesh, almost all the households who had a long-term migration said that they reduced agricultural practices. And reinforcing these findings, we find a 15% reduction in land cultivated over the last 3 years in households with a long-term migrant. Now, to understand the impacts of migration on adaptation practices, I used a matching analysis, matching similar households with and without migrants. And here I present the beta coefficients on the migration term. The color indicates the level of significance. As you can see, the long-term migration of a household member reduces the odds that the household will increase inputs to adapt, while short-term migration increases adaptation through the increase of inputs, including fertilizers, pesticides, and irrigation. Now, taken together, we can say that poorer households use short-term migration to respond to negative perceptions of climate risks. We can also see that short-term migration seems to play a complementary role to agricultural adaptation of practice of farmers in Bangladesh and India, while long-term international migration, particularly in Nepal, is replacing agricultural incomes and reducing incentives to adapt. Now, the key takeaways from both these case studies is that a large number of rural households practice both agriculture and migration simultaneously. Migration is undertaken in response to climatic risk. It's also an important factor in consumption smoothing and helps households cope with the effects of climate change. In some regions, we see that migration is crucial in supporting the household to adapt their farming practices. But this is not always the case, and it depends on the characteristic of migration itself. We also see in countries like Nepal where international and long-term migration can actually lead to declines in agriculture. So in conclusion, I'd like to say that when we are thinking about how to best support farmers in adapting, it's important to considering the changing nature of rural livelihoods, really taking into consideration different dynamics between both farm as well as off-farm practices. So I'll take questions at the end of the session, and thank you. I'd like to invite Dr. Nikki Rasna to give us her remarks.